More rocks reporting from down under. I just want to do another report on the Arctic ice because it's been a major event. We've had the second lowest Arctic storm on record. The strongest storm was in 2012, which absolutely decimated the much thicker ice, and that reached a minimum of 962 millimars. Well, this one went down to 970 millibars. It formed over the north central Siberia and tracked eastwards, crossing Wrangel Island last Sunday and entered the Beaufort Sea on Monday and exploded in intensity. So let's just have a quick look at kind of how it looked. Okay, so I want to go on and just kind of see how the ice looks in terms of thickness and volume and also extent. So we'll just have a look at the normal data, but then I just want to also show, first of all, what has happened to the ice and just how it is broken up and what this might mean. And I also just want to briefly look at the methane. Okay, so this is how it looks today on Earth Null School. It's still fairly turbulent in the Arctic. The winds are, according to this, 36 kilometers an hour up here and about 30 kilometers up here in the Beaufort. So let's just go on. And of course, just yesterday, it was announced that, in fact, not very widely, but it was announced that we have the lowest sea ice extent on record now. And of course, ever since 2012, that's been the one to beat, and we've never quite made it back to there. And so that was the justification why nothing could happen until 2040 or even the end of the century. And this is how the sea ice concentration looks today. Not very many areas with 100% concentration. All of these areas, I mean, 70, 80, 90% concentration. But then, of course, the ice is also very, very thin, as we will see. And here goes another version. This is from the University of Bremen, and this really shows it quite clearly. There's not very much ice there that's left untouched, and that's another version from the same source. I think with these things with concentration, of course, the colours can be slightly deceptive, but of course then you've got to combine that with other forms of evidence. And this is where we've got to today. I'm just going to be showing a video with this after this, which shows the changes. But earlier on, I was saying really that the only area of ice that would be left would be the turquoise area, which of course was much bigger when I was saying it. And now look at it. This is the area of thicker ice, and the rest is, I think this is about 0.5 of a meter, so 1.5 feet, and this is about a metre thickness, so that's 3 feet thick. And this, when I saw it, this really kind of alarmed me, because as well as, you know, cyclones and weather patterns, which is all that they ever talk about, there's been this ongoing process over the years of erosion of the ice from underneath. And you can see why. Look at all this. This is the sea ice temperature anomaly. So all the sea, except for down here, is a lot hotter or warmer than usual. And look at this down here. So this shows the same thing for globally, and you can see all the areas, the whole of the northern hemisphere, the northern Pacific here, below Alaska, just a huge hot blob, and just this hot area above Siberia, and between Canada and Greenland. And these are the actual sea temperatures. So this colour represents temperatures up to 10 degrees Celsius. So is it any wonder? I don't think, I mean, even if there's a you know, a dramatic change in the weather patterns, you know, we've still got this happening, and the sea doesn't cool down that nearly so quickly. And I'm going to be coming back to this in a movie, but this shows I was able to get enough of a gap in the cloud, because the whole of the Arctic is covered in cloud. This clearly shows, this is the north of either Alaska or Canada, I'm not sure, and this is the state of the ice, and it goes right out to the 80-degree north parallel. So here we're going in even further, and this is what's happening at the north of Canada and north of Greenland. So we'll be having another look at that in the next segment. This is how the Arctic looked like from NASA Worldview on the 31st, so that's yesterday. So that's really the latest data that I can get. Just about the whole of the central Arctic basin is covered in cloud, so it's very, very hard. But there was sufficient clearing of the cloud to show what has happened in the Beaufort Sea. So let's just go in, and you can see here. So you can see how the ice has melted here. The ice has started to break up. So let's just have a look. So we'll go in a wee bit closer, and you can see areas where the ice is just breaking up, unfortunately. And then we're into cloud, and we're into cloud here, but there's, yeah, so that is how it looks. Doesn't look pretty, does it? So let's just have another look. Yeah, and then down here. So it's all starting to clearly to break up. And then I'm not going to look at the Russian Arctic, because I don't think anything has changed. So let's just go to the 27th. So a lot of cloud, but I just wanted to have a look. So really this area above Greenland and this part of the Canadian archipelago is completely covered in cloud, but there's also, it's where the last remaining ice is. So let's just go in, and you can see here just how close to the all of these areas, these inlets and things, they're all melted, and then above the Canadian Isthmus and above Greenland, it's melted. So let's just go in a wee bit. You can see here all broken up. I think this is Greenland. Oh no, that's still Canada. And here, this is over Greenland. So this is the area where there is still some relatively intact ice. But I would say anything short of 80 degrees north is just going to go in relatively short order, unless there's some sort of radical change in the weather and we suddenly start everything freezing up again sort of prematurely, but I don't really think that's going to happen. So anyway, so that's NASA Worldview. Okay, so it's this sea ice thickness that really tells the story to me, and if I was to make a guess from the thickness and possibly looking at the sea ice concentration, my guess would be that the only area of ice left would be that turquoise area, and you can see here just how small that gets. So yeah, so that's sea ice thickness. Finally, let's have a look at methane levels, which I really bow to Margot's excellent work, because she's following the levels, the average levels of methane from the NOAA data. But this is something that I've never seen before since Copernicus cams changed their color scheme. So let's just go ahead and just look at the last few days' data.